Hey, welcome back. Good to see you again. Hope you're all well. Today on the bench I have another hk350i. This is a client unit and was brought to me. The lady that owns this has an attachment. It belonged to her grandparents, and she inherited it from her grandparents, and she wants to see it working and brought back to its former glory. Now I did. She was over here, and I did have another 350 that was freshly restored, and I offered it to her for sale. She wasn't really interested. She wanted to see this one brought back, so I said no problem. Take my 350 home, use it as a loaner while this one's on the bench, and then when it's done, I'll give you a call, and you can come back. We can swap, and all is good. So these are great receivers. I really love. I've been listening to 350 here recently, and the phono stage on this blew me away. I don't know if it was something different that they do with the phono stage. I think it's just a regular phono stage that they put in all their series of receivers and amps. But that one really sounded good, so I have a feeling this one's going to be good too. She says it has a problem. It's got a loud hum on the right channel, and so much so that they were connecting both speakers to the left and using system 1 and system 2 and at the same time in mono, and that's how they're getting around it. Very pristine condition. It's a little dirty, the top's a little dirty, but that'll clean up nice. On the back it has a looks like a serviced sticker or a ticket, so it might have been serviced. Although I did have it open and I didn't see anything that was going on with it. So let's plug it in and try it out and see if what kind of hum we're talking about. Here's a look inside. I have the lid off, my bag of screws. Everything looks untouched. It's a little dusty, not bad. It's very little dust. This thing was well cared for, and I don't think it's seen a lot of use either. It's low hours, very low hours. See, there's a little bit of dust. I think I'll hit it with some compressed air, but first the thing I want to do is test the outputs for any DC before I attach speakers. I don't know if it's got a shorted output, and it might be pumping DC out the back. Maybe that's what they're experiencing. So let's plug this in, turn on the speakers. Speakers 1. Here we go. Let's turn this on. Our power consumption went down 16. It's going to come back up again. There it is. So everything looks normal here. Let's see what we got. Ooh, negative 30 volts. That's not cool. Yeah, so we won't be hooking any speakers up to this. This channel is fine. This is 14 millivolts, but this one here is not good. So we got blown output transistors. So let's fix that first, and then let me shut this off. Let's fix that first, and I think I'm going to do a full recap for the lady. I think this thing deserves it. It's got the old TK caps in here, so it'll be nice to get those out and go through this thing and give it a full service. So it looks like somebody's been in here doing some touching up in the solder joints, but they might have missed one, or I don't know why this thing would blow it out. But let's see what we got here. Emitter to collector 0. No. Okay, that's capacitor. Emitter to collector. That's a dead short right there. 2SB690. Yeah, that's our dead short, and this channel will be fine. So might have taken out the drivers as well. So let me see. I don't know if I have any 690s. 2SD726, 2SB690. don't think there's anything special about these transistors. There's a lot we can substitute in there to work. I'm thinking of the MGE15028 and 29. That's a good pair that would fit in there and work really well. It's a low power receiver, so it's not a big deal. Let me fix this first, and then I want to get this so I can power it up and I can evaluate both channels to see how everything's working, switches, potentiometers, everything, and then I can take it from there. The heatsink compound on these is terrible. It's all dried up, and it's not even a paste anymore. It's just a solid. This one here is even. So this could have been the failure point. Look at that. It got cooked, lost its thermal connection to the heatsink, and I think these transistors got cooked. Maybe the bias is too high, I don't know. We'll find out. This one's a little better. This one's not cooked. This one here is the bad one. This one here, I think they're both bad, but that one really looks bad. This one overheated for sure. And also the driver transistors, it is taken out. Now I looked here really carefully with my lens. I couldn't see any cracked solders. I think somebody came in here and did some resoldering, because a lot of this is not wave soldered like it was at the factory. You can tell which was wave solder and which isn't, just from the way the joints look. And some of these have been touched up. So somebody did service this, but unfortunately this killed it. This heatsink compound. Look at it, it's just solid. It's like powder. Alright, so here's a look at all the damage I found. 5 transistors and 1 resistor. So these are output devices, obviously they're gone. I checked the emitter resistors, they're okay. I kept checking until I found good parts. So I checked this stabilizer, it seems alright. And I checked Q414, it seems alright. And pretty much everything else, this wouldn't be affected. I don't think. I can check it anyway. Let's see here. Yeah, I think that's it. I think it's all protected by resistors. R438 is fine. I checked that one. I could check R440, and this transistor I checked. 440's. I never checked R440, but I'll go through and make sure that everything is good here. Especially these two, they're fusible resistors, so if any current comes through here, these will pop. It's 100 ohms and 680 ohms. So I think we got her. It's quite a bit of damage for what happened. Took out the whole channel. R440 is supposed to be 100 ohms, and I measured a 680 ohm resistor in its place. R432 should be a 680 ohm, and I measure a 100 ohm resistor in its place. Now, if you look in the other channel, you can see R439 is 100, and that's what I found there, and I measured 100. Same with 431. I measured 680, and that's what it should be. So these are correct. These are not. These were swapped by mistake at the factory. The only other thing I could see is if the silk screening is wrong on these two resistors. I'll have to go through and check and make sure that 680 connects to the emitter of Q414. But I'll confirm that. Okay, I just confirmed the resistors are in the correct positions. The silk screening for the resistor numbers is incorrect, so that's what really threw me for a loop. So if anybody ever sees this, your board probably has the incorrect silk screening for these two resistors. Alright, new parts are installed. I'm going to check for continuity on the collectors, and then we can... It's good. It's good. Should be okay to plug it in, turn on. Alright, here we go. Power on. That's 26 watts down to 17. Climbing up to 24, 25. So we are live. 28. A little bit of DC offset in the left speaker. I can hear clicking. Seems we might have a lot of bias. Let me check across the resistors quickly. See what kind of voltage we're. $20 millivolts on that channel. 85 on that one. Ooh, that's high. Let's turn that one down. It's supposed to be 33, I believe. Okay, I don't know if you can see that. It's 91 millivolts. Where's our bias? Right over here. Bias is way too high. That's good. Cooked that right channel. No, I was working on this side. That side's the left channel. Turn this down to 33. Wow, is it ever out? Okay, I'll leave it at that for now. Power consumption's gone back down to 29 watts. Okay, we should have audio in both channels. To the left, right, scratchy pots. Yeah, pots need work. Switch seems okay. Okay, repair successful. So now what I need to do is rip it all apart and start my restoration. Start usually with pulling the heatsink out, because you can't get these boards out with the heatsink in place. So that's all got to go. Yeah, I'll just do my regular routine here. Just going through and cleaning this heatsink up, and I really had to scrub the old heatsink compound. Was baked on, and typically I just spray some of the solvent on and wipe it off, but I had to really scrub it off because it was, like I said, it was caked on, and no amount of scraping or cleaning was going to get it off. So this is ready for cleaning now. Now I was looking at this here. I don't know if you can see this. Let me see if I can turn this a bit. This transistor here was baking. Look at how that board is baked underneath that transistor. So that got really hot. Even this one too. I don't know if you can see that if it shows up in the camera, but it's a very slight difference in color from the transistor baking, and that's the reason why these two transistors failed, is because this one is that the PNP one? I think that's the PNP or NPN transistor. That's the one that cooked itself and fried. So heat sinking was definitely an issue. That's what caused this amp to die. So I'll get it all back together, and then we're going to be done. I'm done with the recapping of the amplifiers. I haven't touched the tuners yet. I'm going to recap some of the tuner. I'm going to get rid of the TK caps. I don't know about all of the caps. There's not very many in here. There's maybe 10. And I'll address that before I close this up. And then I need to address these switches. They need to be cleaned. Even though they weren't acting up, I'm going to clean them anyway. And everything else is done. The tone board's done. Pots are cleaned and treated and recapped that as well. That's all done well. So we're getting close to the end of this. Alright, everything's back together, and I think everything is ready to go. Did have one hiccup. Put this bar antenna in upside down because it is facing downwards. It should be facing upwards. The result is, I noticed the electrical connections are touching on this heatsink, metal heatsink, so I have to remove the bar antenna, flip it over. That's good. I'll fix that. Looks like somebody's been in here reworking the lamps. I think they replaced the lamps, the dial lamp, not the indicator lamp, but the dial scale lamp, and they wired them in series. These two lamps are supposed to be in parallel, but somebody wired this in series. Not a big deal. I think what they did is they changed the bulbs to maybe a lower voltage, and they wired them in series just to prevent the bulbs from burning out. I'll leave that alone. I'm not going to touch the lamps in this because the lighting's all working. So next I'll have to do power up and bias adjustments, DC balance, and we'll get that all sorted, and then we'll on to power tests. Just went through an alignment of, well, I did the bias adjustments and DC offset, that's all fine. I went through the AM alignment, that went really well. It actually brought in a lot of sensitivity and made it a lot better. Now I'm going through FM. FM's pretty much spot on. There's a few things that I touched on. The discriminator was off a little bit on the A block, so I centered that, and just going to shut off the signal generator here. Making a lot of noise, and the FM band is working pretty good now. Let's do a quick scan. Got a good separation when the stereo kicks in. No antenna, but I should be picking up more stations, but with an antenna this thing will rock. If I turn off the lights again. Getting stereo on every station.
Just 2 minutes. With 96% of applications approved, go to iCash.ca.
This one's pretty weak.
Download the iCash app now and get the money.
Yeah. Yeah, so it's working pretty good. Alright, let's do a power test out of the way so we can get this thing finished up. So I have everything set, I believe. I just got to turn it on, and should be ready to go. There's our signal. Let's turn off the speakers, turn on the load, turn this thing up. Okay, clipping. Let's turn it down a little bit. Right about there, I think. I think that's peak. We got 15.38 volts RMS on 8 ohm load. So we'll just let this go for a bit. Timer. Start our timer. Now, it's a lightweight. We only got 118 watts going in, and I think we got about 30 going out each channel. So we'll let this cook for a while, and we'll see how it does. Alright, we're at the 10-minute mark here, and things are looking really good. This is still, well, we're right at about 60 degrees Celsius, which is what you'd expect. It's holding out really well, and let's see if we can get this. No, this won't read. If I can get a reading, doesn't want to pick up on that, but we're good. So we're going to turn it down, and let's do some square wave tests quick. Turn this down a bit. I don't want huge volume. So we're at 1 watt right there. Let's turn this down, turn that up. Okay. Alright. So this is our bass cut. Bass boost. So we're looking good and clean. Treble cut. treble boost, balance. Controls really turned out good on this one. This is our stereo blend knob, doesn't have any effect. No effect whatsoever on a mono signal. This is our tape monitor switch, looks clean. This is our inputs, phono. Okay, this is our loudness. It's pretty typical. Volume control. Alright, let's go down in frequency. There's 60 hertz, 30, 20, 10. Looks alright. Kind of cut the bass and boost the bass a bit. You see the difference there at 10 hertz. Alright. It's 5 hertz. Got a little bit of tilt at 5 hertz. It ain't bad. It's doing a lot better than most. It's 2 hertz. There's the tilt at 2 hertz. Okay, let's go up. One kilohertz. Let's go up. 10 kilohertz. 20 kilohertz. Looking not bad. See how far it goes. Start to lose it right around here. 55 kilohertz. Yeah. Looking pretty good. Alright, here's a look at what parts went into it. This is the repair we did at the beginning. 5 transistors, 1 resistor. They all blew up the whole channel. This was because of this. You see that scorch mark on the back of the transistor. That's excessive heat, and this stuff is completely dried up. All of these are completely dried up. The heatsink compound failed in this instant and caused the amp to blow up. This one here has failed too. So that's the original failure, and then I went through and removed some bodges, some resistors and a capacitor, and I did some reworking of the ground. Got rid of some long ground runs and got that, and then we did the recap. This is all the caps that went into it. The TK ones, for the most part, they were okay. This is a low hours receiver. These Masashita ones, that's a different story. It doesn't matter how many hours you got on a Masashita cap, it's going to be bad. These 10 at 16 volts are the worst. And if I measure one right now, so this Masashita cap is a 10 at 16, 10 microfarad at 16 volts, and it measures at 6.5 microfarad, 36 ohms ESR, which tells me that cap is done. And these Masashita caps are used typically in the tone circuit, the preamplifier tone circuit. So that's good to get those out because you get a better balance of sound between both channels when you put brand new caps in. So that's it for the parts. Alright, that's it for this one. I'm going to end this one here. Pleased with the results. I hope the owner is pleased as well. I'm pretty sure she will be. So this is going to wrap up this video. I'm going to bench test this for about 2 weeks, make sure there's no issues that crop up, and then we'll give it back to the owner. And so thanks for watching, take care, and we'll see you on the next one.